thanks for checking out our channel here. This is going to be, I don't know if it'll be a repair video or not. Definitely a testing video. This is on a Gallagher B1200. These were, man, some of the best battery units ever built by any brand, period. This is from 2004. This is the unit, serial number on it. I've actually got two of them here from the same customer. The other one is late 03, so I probably bought around the same time. This is a early 04 model, serial number. The other one's a late 03, so probably around the same time the guy bought both of them. He said they've been basically running non-stop for the last basically 20-some years, and hasn't had a lick of problems out of them until last summer in 2024. In the summer, he said one is his hired hand. Couldn't remember exactly what the story was with them. He thinks one of them worked, and, came on and operated, but like no output or weak output or whatever, and the other one didn't come on at all. I said, well, parts for these are very rare, if not at all available. Main modules for these things got discontinued this unit got discontinued as a production model in like 2008 or 9. It came out with the B1600, looks basically just like it. So it was a black case. Same look, size, shape, and everything, but the guts were different. Different main board, different capacitors. I think the output board might have been the same. Possibly the same transformer. I know there was two different transformers at one time. I think they went to one for all their big battery units. But a variation of this unit came out in like early 90s. So by the time this guy bought it, it had already been around, 15 years. So, but we're going to take it apart here, and I told him, said we may or may not be able to fix this, depending on what's wrong with it. I said maybe we can take two units, it's two units, make one good one. So, oh, yeah, that might be a good idea. We try to do that. So we're going to see. We're going to see what we can do. The thing's 21 years old. Gallagher builds almost all their own stuff in-house, not everything, but a good chunk of it. And this whole generation of unit, really, really good. So there's the inside. You got your main module, they call it. Your output VDR board, which is a lightning protection board. And the two big capacitors here. You got a on-off switch, which is stuck in the on position, which I don't want to push too hard and break it. You got a high, medium, low switch. Looks like the power battery cable's been replaced. They put some kind of red-black cord on there, and it JB welded or silicone shut. So it'd stay put. But what we're going to do is we're going to hook up power supply to it, and we're going to see what happens. This is holding on by about 4 pieces of wire, and this one's pretty rusty, so we may end up changing those or cutting them off, and he can put new ones on. If I don't have the same, I don't know if I got the same size ring connectors on hand, but he can get those at any hardware store, probably even Walmart. Let's see here. Cable, my power supply. I believe that this unit would run off of 12 volt all the way up to 36 volt. So we're up all the way to 36 volt system on it. It would last a lot longer if you didn't have a solar panel hooked up to it. So I think that's why they have a 36 volt setup for it. Alright, our power supply is hooked up. There's no draw on my power supply, no amp draw. So this thing's, and it's not turned on, there's a little light bulb right there. It's supposed to light up green. Oh, it is lit up. I couldn't see it. Okay, so it is on, but it's not clicking. It's not firing. So what is that? I couldn't see the light because the way the angle was, I couldn't see it lighting up. But it is lighting up. Let's pop this wire off. This is for our switch, the 3-position switch. Pretty nice little board. Okay, you can see where they've wired it up and everything. Let's I'll apply power back to it, and we're going to trace power with the board out of the way, make sure we're getting, power where we need it. I guess we are getting power where we need it because the light was turning on. So, stop that deal. So it's not clicking, not discharging. So, it could be the board. board looks okay, but looks can be deceiving. So the first thing I'm going to check the primary of the transformer, which is down here. It should be between 0.1 and 1 ohm. 0.4, 0.5, so that's fine. Got two capacitors here. These are 30 microfarad capacitors, two of them. They're wired in parallel. If you don't know electronics or don't understand, capacitors in parallel add up. Where like resistors in series, they add up, but resistors in parallel, they divide or whatever. And capacitors in series divide, whatever you want to call it. So it should be 60. I'm getting 47. So, issues the board. There's no schematics. It could be this coil thing here, but there's nothing written on it. I think that was made by Gallagher in-house. So, and they'll offer this board and they'll offer that. Now there's a piece right there. Of course, I can't read the number on it. I mean, it's off the shelf part, of course. But it's so, I don't know. It's a transistor of some sort. I'll play the board for a moment, and then I'm going to move on. I'm going to go grab this other unit. We're going to take the board out of that one if it's good. Just testing the diodes. They'll look good, but the only way to know is you gotta test. Can't assume. I don't know if we can. Okay, that's the right terminal. Because that one's good. Yeah, that one's good too. How did I have that before? This one could be bad. Can't frickin' read the part number on there. Damn it. Of course, Gallagher doesn't have schematics. They only stocked this board. They made this board since like 2015 or something like that. So let's move on. Let's grab their other unit here. Sit on top of this one, and I'm going to just apply power to it. Because I think he can remember, but he thinks his hired hand said that one of the units powered on and the other one didn't. Well, the one did power on, but didn't put nothing out. Didn't click. This one, the switch at the bottom here is busted off, so I have to see if that thing's already in the on position or not. Let's just turn it on so it happens. Alright, it doesn't turn on at all. So the switch could just be bad, or broken, and it could be stuck in the off position. So let's just, I'll put the cover back on this other one real quick. I'm going to set it off to the side. Get the cord out of the way. Let's get this one opened up. We'll test those capacitors real quick. It's got the original ones in it, like the same one did. So these capacitors are 20-some years old. Oh, well, hold on. Let's pull this board out first. I might be getting an inaccurate reading. Board's 2010 board, so the board's been changed. Now those read about 55, and those are, together should read 60. So these are actually better shaped than the other one is. Okay, let's see. Let's test this switch and see if it's actually on or off at the moment. All right, switch is on. Let's. It didn't come on at all. It didn't show any signs of life. So let's turn it on. The power supply. Let's trace power. It's like a negative's right here on the DC volts. Positive comes in right here. All right, getting power all the way through. Check this wire on one side of the fuse. Good. Back side of the fuse. Shit. Alright. Well, I think we got problems with boards in both of them. Shoot. Because boards are no longer made. Let's hold on here. I don't know if what part that is. I mean, this one's a little easier to read. The numbers on it are a lot more clear on it. I'm trying to read that deal. Part number on it says possibly. Oh man, need eagle eyes to do this. 1RF640N. I don't know. I don't know. So we know the fuse is good. Let's, for shits and giggles, let's put this one into here. Oh, hey. Huh. This board from the other unit works in this thing. So that must mean that we've got an issue. We definitely got an issue with this board here. Uh-oh. Okay. There it goes. Has a 3-position switch on the outside, high, medium, low. And the Gallagher's battery units all did that winding up noise. They all did it. The small ones are a little quieter. These mid-sized, bigger ones were... Plus the case is all open off of it, so that's one other reason why it sounds the way it does. Let's put a meter on and see what kind of voltage we get out of it. Okay, we were only getting... about 4,500 volts out of it. If you look at this, the light's not flashing every time. No, now it is. But, no, it didn't. But it takes about 4,000 some odd volts or more to make that light flash every single time. So I think what we got wrong with this as well, we'll probably keep this board in this one, but this has got probably a bad transformer in it. Okay, let's turn this power supply off. So now what we can do, or maybe this output board's bad, but maybe if the transformer's good in the other one, we can take the transformer out of that one, stick it in this one. Let's take this transformer out. Set it there for now. a black transformer. That's the original one. Later ones were brown, so that's the original transformer from 20-some years ago. So now what we'll do is we'll put a meter across the top of this. If the spike's way up high, which it doesn't, but if it did, transformer is good and the output board's got a problem. If this stays down low like it is, 4.5 kV is all we're getting out of it, then the transformer is bad, which that's what's wrong with this one. Transformer is bad in this one. So let's put this cover off the side for the other one. Let's get this transformer out. Put light on so I can see better. So we're gonna unplug the red wire and the black wire off the bottom. Get this transformer clamp popped off. These plates pulled out. Transformer, yep, just slide right out. That's original transformer from 2003 or 4, because the replacement transformers would have a sticker on one of the sides with a part number and a new serial number on there. And the factory ones put in from way back when did not have a sticker on them. So that's from 2003, 2004 time frame. All right, let's move this out of the way for just a moment. Let's get this one popped back open. I'm going to hope that the transformer in this one is good. Don't know, because I can ohm it out, I guess. Let's see what this where I put the other one at. Okay, the other one's right here. We'll ohm out the output side of each transformer and compare. This one probably be, I don't know what it's supposed to read, but it's probably going to read low, or fairly low ohms. And if this one reads a bit higher, we know that this transformer is probably going to have a higher output voltage. So this one reads 11 ohms. This one reads 8 ohms. So yeah, this transformer is fine. I'm assuming it is. So good. I think we'll be able to save one of them, keep one of them from being thrown away. Let's see. Oh, there it is. So I told him we would try to possibly save one of them. Take parts from one to fix the other. Ooh, okay, good. That transformer slid out. That's the original transformer too, so we'll just have to take a chance on it. That's all we can do. What else are you gonna do? Throw it away. Okay, we're gonna have plates. These are part of the lamination plates. These aren't magnetic. These are just part of the core of the transformer to transfer the energy from the primary side to secondary sides. All these lamination plates will use for are steel, so that's why there's rust on them, but it's just surface rust and it won't hurt anything. Not going to cause it to have that much of an issue. I'm not going to sit there and clean every single one of them. No point. Come on. Get one more in there. All right, needle nose, where are you? All right. Okay. Black wire goes here. Red wire goes there. This was the original output board. It looks okay. Slide right there. Make sure that those tabs are straight. Just pop right in there. Oops. Okay. I'm ready to put this heat sink back on here. Alright, let's, power supply is on. Our power supply is hooked up. Let's turn the power supply on. Alright, let's take our meter here. I don't know what is on. We're going to go across fence to ground and full power, which is the red terminal. This terminal, or switch down here is in the middle, which is high. Up is medium, down is low. It'll drop down by about 1,000 volts plus or minus each time you go from one setting to the next. So this should be the max voltage output. There we go. You're getting about 9,000 volts out of it now versus the 4.5 it was getting before. About 9,000 volts. Now we'll go to medium power. You'll hear this change. The clicking sound, the speed, the winding up noise is shortened up a little bit because it's discharging a little quicker. See, we're down about, down about 8,000 roughly. So we're down about 1,000, 1,200 volts. And we'll go to low power setting. So now it should go all the way down to around 6.5 to 7. So 6.5 to 7. Get back to full, and there you go. All right, oops. So this one's raring to go again. So we saved one of them. We'll just charge them a little labor and call it done. I guess I could ask him about the switch. I guess we could possibly take the switch deal out of the other one, but then we're dealing with a stupid cord. I don't know. It's got alligator clips on it. If you guess the guy wants to kill power, just unhook the battery from it. It shuts it off. Or we can put another switch in it. We'll pull that switch out, and this is a standard. It's a different kind of shape of one, but it's a standard. Just single pull, single throw switch. Nothing fancy there. All right, well, I'm going to write them up for at least this one. And I'll just look at the case on both of them, see which case is in better shape. He said whichever one we can't fix, just to keep it for parts, I guess. Probably put this case on it, because the other one's got a crack in the top front of it, so we'll probably just put this case on it. And this capacitor's a little low, but it's 55 out of 60, 54 out of 60. It's not losing all that much of energy. So change them, I think, would be a waste of money. Doable, but I don't think it's worth it right now. So let's see what kind of spark this thing throws. Oops, let me get the power supply hooked up right. Come on. Yeah, it quits it once in a while. I got a problem with the cord. I think it's this thing right here. This stupid. I hate the spade connectors. The non-insulated ones. Cheaper and more plentiful, but I like these fully insulated ones like this. Copper's nice and clean, nice and shiny. Oops. Crimp that on. Look at the pins down inside there. They look clean. Let's put a little dielectric grease on there, and we'll. Oh, you gotta bend these a little bit. There's two tabs inside there. I'm gonna use one. I'm gonna use the opposite one from what they were using, and they gotta bend it because it's. So we're gonna seem to get back behind it a little bit. There we go. Line it up. I like the newer clamps they use now. Their little openings are a lot wider. You can see down the side they're a lot easier. Look at this one real quick. Yeah, we better change that one too. That one's pretty crunchy, crusty looking too. So get another one of them pink, red spade connectors. Put a little dielectric grease on there. Get it lined up. Just go to the back side and press it on. There it is. Whoops. Alright, let's put the power supply back to it. It should just pop right on. It shouldn't have any delay. Intermittent things like it was doing before. See, every time I touch it, it turns on. So now we're not having the trouble I was having a minute ago. There we go. Alright. Another one's going. Yay! Alright. We're going to call it quits on this stuff, and I'm going to move on to another one. There's our information. Remember to subscribe, tell your friends about us, like the video. Talk to you later.